So this recording is for the virtual applet lab parts in this Pendulum lab. And here's the link. And I can either copy the link and get there. There we go. And there it is. Takes a moment to come up, I guess. There we go. There it is. Or I can Google it. PhET is very unique. And I know it says on my computer it shows up in German. It's German, so there we go. There it's in English. And then under simulations, go to physics, scroll down wherever you find a pendulum. There are quite a few applets here, simulations, and here we go. And as I said, one of them is a pendulum, but I already have it open, so I'm gonna go to this one here. So I'm gonna start it. And then I really don't know the difference between intro and lab, so I'm just gonna do the lab here. And there's a number of things available here. I'm gonna click on ruler, so I have that one available. And my table here in the lab says 33 for an example. I'm going to skip that because I already did it. So I'm going to start with 44, 55, 66, and so on. The lengths really don't matter. You know, those are benchmark figures. I just chose those 44, 55. You could choose something else, but might as well use my numbers. So 44, I'm going to change this one here to 44. There we go. And you can see this measures here on the ruler, starting at the suspension point to the center of mass of the pendulum weight at 44. So there we go. Then I'm going to take it out in small angle because that's what it says in the lab manual, small angles only. I personally don't start the stopwatch. By the way, here's the stopwatch. I don't personally start it when I let this pendulum first swing, but I start the stopwatch whenever I'm ready, such as now. I'm going to say ready, set, go, and then my first count for the pendulum is not a 1, it's going to be a 0, because when it starts, it's 0 swings at that point. So I think I'm going to start on the right-hand side. So ready, set, go, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. 13.39. I'm gonna just jot that down here. I'm gonna stop this one. There we go. Change the length to 55. And again, you can see that is 55 right there. There we go. Reset the stopwatch. Again, small angle. And then ready, set, go, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. All right. Again, reset and go to 66 centimeters or 0.66 meters. There we go. Again, small angle. And ready, set, go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 16.39. Okay, I'm going to stop this one here, and before I go on with the applet, I'm going to go over here to the table that you find in the lab manual. And so this is what I had: 13.39, 14.95, 16.39. There we go. Then it says 10 swings. You saw me do that. So all I have to do for the period is divide by 10. And obviously I can do that in my head. For the actual pendulum, that's a few pages down, I actually ask you to do 20 swings. And it should say that somewhere in the in the lab manual, do 20 swings right there. So anyway, back to the virtual lab here. I'm going to compute that one here. Oh, there I made a mistake. That's 1.639 as I divide the time by 10. I'm going to calculate the acceleration due to gravity. This is the pendulum equation rewritten for the acceleration due to gravity. So I'm going to plug in 4 times pi squared times 44. And I didn't make up that equation for the pendulum, but that's it. That's what physicists figure out is the equation for the pendulum. So we're obviously going to use it. I'm just going to do the last one here, the 66. So 66. Nope, I already did that. Okay, I'm sorry, I made a mistake here. Hold on. I meant to say right here, this is my 66. And then for the time, I'm going to use, obviously, the period 1.639. So sorry that I almost messed that up here. And hit enter and cross my fingers that I come up with something close to 982. All right, 970 rounded. I like you to round to the nearest integer in this case, which is also 3 significant figures. Notice that with the 66, we actually only have 2 significant figures. So it could be a little bit off. I'm actually a little bit disappointed. I thought I might get a little closer, but obviously I didn't. Maybe it's because it swings quite fast, and I understand it's tedious, but still, it swings actually relatively fast. And you know, if you're off a few hundredths of a second, it could be off already a little bit. 970, by the way, is only off by a little over 1%. And this is how precise you have to be in this virtual applet lab. As I said, I was hoping to actually be a little bit closer, respectively, in the actual lab as well, within 1% approximately. That's why it says in there between 970 and 990. Okay, I'm going to take the other data here. So this will be 477 centimeters. There we go. Let it swing. And start the stopwatch. Ready, set, go. 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, again, jot that down. Stop, set, 88 centimeters. Take out there. There we go. There's no depends on the angle. In fact, you're going to see that later on for another table there. So here we go. Ready, set, go. 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 18.85. Oh, great. I'm trying to jot that down on my pen. Almost gives up on me. Set everything, go up to 99. All right, again, take it out a little bit. And let's see how good my French is. Let's ready, set, go. 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Okay, my pen on my desk drives me a little nuts. Okay, reset, but gonna put these over here. So 17.63, 18.85. I would like you to measure yourself, but if you really want to use my measurement, that's fine with me, because this is just practice for the real thing. Oops. There we go. Two. And again, I'm going to pick the last one. Graphing calculator, by the way, really nice. I can just go to the last one here, second entry, and there it is again. And now I'm just going to fix some results here, or some measurements. 66 becomes a 99 now. And then I don't have to retype the whole thing. 1.9, I said 1.992. There we go. Enter, and 985. And then I have to pay attention to something, which was that now that I have recorded here for 11 minutes, this one is actually set for 9.81. I meant to set it for 9.82. The applet, of course, is more or less perfect with the software behind it, but of course I still have to make the measurement, which is, it contains my own error. As I said, I forgot to set this to 9.82. I'm not going to repeat the whole thing. So here, you ought to come up with numbers really close to that 981 or 9.81. In this case, it's of course centimeters per second squared. On the next page here, you just have to do an average of these data that you get here. That shouldn't be really tough. And there's also an Excel sheet that you can use for that. All right, I'm going to give myself a, well, actually, I'm going to scroll through here and then I'm going to give myself a break. So this is the actual experiment that you have to set up. And again, these are benchmark figures. So once you actually set it up, you don't have to use a 100 centimeter string. If it's 98 centimeters, that's fine. Then you just take that out and you put 98 there, and so on. And then again, here's the average. Okay, I'm going to give myself a break, and then I'm going to do these tables here. All right, so here's the next part for the virtual lab for the pendulum. Just back to this little table here. So notice that I didn't write the unit behind here for any one of these numbers, and the reason is in this table here the unit is on the top. So you will see that for tables throughout this semester in my labs that sometimes they're written on the top, sometimes you actually have to add them in here. All right, so going here, so this was again is the actual experiment. And then here, I stopped at the wrong place. These are actually tables 3 and 4. Those are actually skipped. Instead, we're going to do tables 5 and 6, which is using the virtual lab to see that there is no dependency on the mass. You will find that out. I tried to only highlight this right there. And then that there is a very slight dependency on the amplitude. All right, so let's do this one here first. Pendulum length 62. One swing. All right. Okay. I guess I don't want to bore you, so we will only do one swing. And let's see, it said actually 100 grams, 62 centimeters. So I'm going to go to 62 centimeters. And then I'm going to go to 100 grams. There it is. All right. Okay. Yeah, I'm just going to leave it at that 9.81. That's kind of like Southern Canada. And then I'm going to let it swing. And then I didn't tell you before, there's a cheating way. It's called the period timer. There it is. And when you start that, this is what you're going to get. It only calculates for one swing. Ready, set, go. And there you go. I mean, this is really, yeah, not really a measurement because I'm just going to let the applet kind of dictate when it starts and stops, and it should be perfect, right? So I'm going to stop it again, and I'm going to do 0.2 kilograms. I think that's what it says next. Yeah, 200, 300, 400, 500. There we go. So there it is. Try it. There we go. All right, again, let it swing. And the period. And stop. And go up to 0.3 kilograms. Let it swing. And the period. There we go. You might have noticed that there was no difference between, oh, I meant to change this one here to 0.4. No difference between the last two measurements. And there, that's the same as the first one. There's, as I said, there's a slight angle dependency here, which actually does show up. This is basically about the mass, though. And so here we go again. This is 500 grams now. And there it is. And then the last one, again, stop. 600 grams, there it is. And there's the period timer. There we go. Not as tedious as the other one, right? But again, this is kind of like almost cheating because I'm really relying on what the software is telling me. So these are the measurements that I had here. And this one here is, because I only did one swing, my measured time is actually the same as the period. There we go. And then the fourth one was this one here. And again, the period is the same. The second one was actually, there was a 1 there. And there was a 1 on the third one. And there was a 3 in the back on this one here. And then if I copy those, there, and there. There we go. And there was no pattern that you can see here. You know, it's not going up and down. No, no, no. This is like in the fifth significant figure, you know, and the pendulum mass dramatically changed from 100 grams to 500 grams. I guess the 600 here didn't matter after all. So, yeah, there's really no difference here. And again, I'm going to give myself a break. So obviously on the last one, I didn't have to do anything with the calculator. Same thing on this one. So this one here is for the angle. Let's see, it shows 93 centimeters and 800 grams. So I have to find my lab again. Oh, there it is. All right. Okay. So what did I just say? Gosh, 93, 800. I have a very bad short-term memory. But then again, I'm also focusing on a lot of things here as I'm preparing this. This is for all my videos. There's a lot of things on my mind because I'm recording myself. I have the narrative, and I have to have whatever equipment I choose, and trying to pay attention that I don't say too many uhs and ums and so on. So this will depend on the angle, and I guess I'm going to take the period timer again, and the angle are going to be 5, 25, 45, and 65. All right. So I'm going to get this out to 5 degrees. There it is. Let it swing and start the period timer. And there it is. 1.9355. There we go. Stop. Change the angle to 25 degrees. There it is. Hit this one. And there we go. And if you remember the last one, that was 1.93 something. So this one is 1.95 something. Though this one already changed in the third significant figure. So there is an angle dependency already. Let's see what happens for the 45. There we go. And period. And there, you can see that, right? And the 65. right. So here are the results. Now, if you were to measure that with a handheld stopwatch, you know, you're between 1.9 and 2.1 seconds. Actually, you know, your reaction time is at 0.1 seconds approximately. It could possibly actually show up. It probably does actually by these large angles. But in order for the first one, table 1, and then later on table 2 for the actual experiment, in order to come up with good results, you need to stay at the small angles, because the large angles will actually not exactly follow that pendulum equation. The pendulum equation that I gave you here is independent of the angle of the amplitude as long as the amplitude is small. Okay, so we do see angle dependency or amplitude dependency here. Again, if I go back here to the mass, yeah, there's no difference. You know, no matter what mass it is, you know, 5 times the mass, 3 times the mass, there was only a slight difference in the 5th digit, and I think that was actually because I didn't have the exact same angle all the way through. All right, last one to do will be as if we were on the moon. Again, I'm going to give myself a break. All right, so I'm going to do 10 swings, so I take actually real measurements for pendulum lengths of 74 and 91. Oh boy, that's going to be tedious because the moon's gravity is quite a bit slower. I actually have to tell the PhET to change the gravity to the moon. And yeah, because it swings slower, this will take us a little while. So here we go. I don't need that period timer anymore. I'm going to change this one here to the moon. So technically we ought to come up with, there it says 1.62. So let's see what's going to happen. And what did I say, what pendulum length I take? 74 and 91. Right. Again, those are benchmark lengths. I could use other numbers, but you know, I'm fixed there. It didn't say anything for the mass, and it's mass independent anyway. And again, I'm going to do small angles. So here we go. We are on the moon and we're fine. And I'm going to start 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And that was for 74 centimeters. And again, the other one I think was 91. Yes, 91. Again, if I chose accidentally a different number, then I just need to fix it in my table. I do the 91, and you can see again here the ruler shows that the middle of the weight there is 91 centimeters. Okay, reset this one here. Small angle. And 0. 1. 2, 3, 4. I guess I never threw in Spanish here. 5, 6, 7, 8, 9, and 10. All right. Okay, I'm gonna go over here. Whoa, okay, something really strange happened here. Okay, all of a sudden I had stuff all over. Let's see, so here are my measured times, 42.50 and 47.27, which means 4.250 because I did 10 swings, and 4.727. There we go, so this is on the moon, and I'm going to use the same formula here, of course. The pendulum formula is the same, obviously. Now, of course, gravity has changed. I'm going to go back here, and so I did second entry again. This is really nice on the TI-84 with the second entry one there, and then I can just write over previous numbers. And this one here is going to be 4.250 squared. 161 or 1.61, I have to see. Oh yeah, centimeters per second squared, that's how I'm going to do it. Second enter, and go back here. There we go, 91. And 4.727. Enter. So the first one rounds to 162, the second one to 161. 161, and if we compare here, PhET tells us that the moon is 1.62 or 162. They have it in meters per second squared here. I have it in centimeters per second squared. So notice that obviously the applet is very accurate in what it's doing. The actual experiment for the pendulum, well, turns out that it's actually also very accurate. So going back to these results earlier here, yeah, you ought to come up with numbers really close to what the virtual lab shows here, 975, 970, 985, and whatever you calculate over here, so that in this table here, yeah, those numbers are also really close. Notice that these are my examples, 976, 981, 977. So you cannot be all over the place. You just cannot. You measure accurately, and you ought to come up with something that is close to 982. As I say, I think it says somewhere in my lab manual here between 970 and 990 is acceptable. All right, I think I'm finally done with this.